Go. Hello, Mr. and Mr. Ryan, are you right? We talk about the largest sublist sum, yeah? Largest sublist sum. Sublist, sometimes we call it subarray, okay? What's so funny?
Nothing.
What's the difference between sublist, subarray, and subset?
It's continuous!
What?
It's continuous.
Which one is continuous?
Those two.
These two are continuous, okay? For example, like let's do this. 1, 2, 3. This is an array. So can you give me an example of a sublist?
3. What? 2, 1.
Yeah. 2, 1,
3.
3.
1, 2, 3.
1, 2, 3. Okay.
2, 3, 1.
So these has to be
3, 1,
no. 2, 3, 1 is not. 2, 3, 1 is not. So that continuous.
So.
Yeah. Continuous. 1, 2, 3. 1, 2.
1, 2, 3, 4, 5,
1,
6, 7, 8,
2,
9,
3,
10,
1, 2, 3.
11,
Okay.
12,
So
13,
basically, look.
14, 15, 16, 17,
1,
18,
2,
19, 20, 21,
eh?
22, 23, 24, and 25, 26, 27,
1, 2, 3. Okay.
Yeah.
Yeah. Continuous.
Yeah.
Can you give me an example of subsequence?
1, 6, 9, 8, 2,
1,
4, 3,
Sorry?
1, 3.
1, 3. Okay. Not continuous, yeah? Not continuous.
1, 2, 3, 4, 8, 9, 6,
Yeah.
4, 3.
And all of the others.
All the others. What do you mean?
Because subsequents don't have to be, you know.
Subsequence don't have to be continuous.
Yeah.
That's right. So all these are subsequent, right?
Yeah.
Am I right?
Yeah.
Sublist
That's
is
what I was about.
yeah. Okay, so
trying to
sublist
say.
is part of a subsequent, yeah? This is kind of in. That means in, okay? Subsequent. So if we draw a set, yeah, here, that will be sublist. And then here will be subsequent, okay? Because subsequence includes the sublist, okay? Okay, that's it, no more. Yeah?
Yeah.
So for problems like sublist, we can always do what? We can do what?
We can brute force.
Brute force, and that's going to take roughly what's the time complexity?
O(n) square.
O(n) squared.
O(n) squared.
Why is that? Look, because we can pick one pick the start of the sublist, and then we can pick the end of the sublist, right? So that would be like a nested for loop, and that's going to take O(n) squared time. Okay.
Yeah.
If it's a subsequent, right? Because if it's a subsequent, the time complexity, if we brute force it, it will be O to the power of n. Yeah. Because for each element, we can pick or not pick, right? Yeah.
Yeah.
So 2 times 2 times 2 times 2, that's 2 to the power of n. Okay. So usually subsequence is the problem is more complicated than the subarray. Okay. So for this kind of problem, brute force, we can do this. We can do it in brute force. Okay, let's quickly do it in brute force. So, okay, I think I'm running out of ink.
You can use my pen.
Define largest sublist sum. Okay, sublist sum.
Bomb.
Okay. So we just have to brute force the left and right index, right? The left and right index. First of all, the answer is minus the mass infinity. And then n will be the length of the numbers for I in range n, right? For j in range, we start from the I, the left boundary. I is the left boundary, j is the right boundary. And then the current sum
yeah,
will be sum numbers start from I to j plus 1. Yeah, because up to
J
j.
plus 1.
And then answer
Plus 1.
Answer equals what? Maximum of answer and the sum. Okay. Return answer.
Answer.
What's the time complexity? This one.
N squared cubic.
O(n) cubic. Because this is O(n) time, right? But we can easily optimize it. This is O(n) squared. O(n) cubic, sorry. but we can optimize it because this is every time for each subarray we don't need to calculate the sum, right? We don't need to calculate the sum, okay? So how do we do that? We just have to, how do we optimize this into O(n squared, Eric?
We make it quicker.
Look, we just put a sum here, s equals 0, right? So instead of summing, because this takes time, right? This takes time, but we just do this. S plus equal nums j, and then that will be it, right? Look, here in this case, this is O(n squared, right? Do you see how we do it?
Yeah.
This is slow. Why is that? Because every time we have to calculate the sublist sum again and again.
Sublist bum, actually.
Why is that? Look, 1, 2, 3, 4. We know this sublist sum is 6, right? Yeah? Yeah.
Yeah.
Okay, what's the sublist sum this way?
Yeah.
This is, I told you, here, this is 6. If I include one more number, what's the sublist sum?
Sublist sum is 10.
Exactly. How do you get the 10?
6 plus 4 is 10.
Exactly, here, right? But previously, this one, it does not do it. Previously, you will just do it very stupid. 1 plus 2 plus 3 plus 4.
That's not
That's-
stupid.
That's how it's very slow, okay? But we are now changing it because we already
That's
know
not
this.
stupid.
Okay. We are now knowing this
It's
is
just
tricks.
clever.
Plus another one, right?
It's
Plus
not
another,
stupid.
accumulated.
It's just well done.
Okay, so Kadane. Yeah, we also know the Kadane. Ryan, what's Kadane?
Kadane is, I forgot.
Okay, but you know this is Kadane. There's a Kadane solution
Kadane.
to do it, yeah?
Sublist bum.
So how do we do the Kadane, okay? So look, 1, 2, 3, minus 4, minus 5, something like that, okay? So let's say the Kadane is like the iterated dynamic programming, and we talk about it. So if we saying dpi, this is the maximum sublist sum that ends at index I, right? So it actually equals to maximum of, come on, can you come down? Otherwise people not seeing it. dp I minus 1 or 0 plus nums I. Okay, so this is the basically a dynamic programming. What this means is that dpi, come on, listen to me. Is the largest sublist sum that ends at index I, right? So it equals to the previous one, right? If we pick the previous one, or we don't pick it, we start as this number. Okay, Ryan, come on. So look, you are here, yeah? dp, we are here, dpi. So we are considering this number. So this is, we are considering this number. So there are basically two choices, right? So if we include this number in the previous sublist, right? So you will have one more, right? Or we don't include the previous number, so we start it as a new list. So the sublist start with here. So basically there are two choices. That's what it means, right? That's what it means. So we can do this. Let me just write it, okay? Define largest sublist sum, SS numbers, okay? Okay, so if no numbers, we can just do it. If no numbers, we just return 0, okay? And at least we got one number, so answer equals the current equals num0. So we start with the single number. Then we start from the second number. For I in nums, start from the 1 to the end. So current equals the maximum of current plus I or I. Okay, so this is basically saying that, okay, let's try two possibilities. One is to include this number in the largest sublist sum, or we start a new list with a single number, current number, okay? And then answer equals maximum answer sum, okay? Current. Return what?
Answer.
Yeah. What's the time complexity if you look at this? Come on. Okay, answer equals maximum, okay?
Hi.
So make sense.
I'm bored. I'm gonna finish.
Yeah?
I know working.
Yeah.
Okay, so now come on. Today's problem is look one slightly different. Is we want to find out the continuous subarray which has the absolute value ABS. So nums I plus num I plus 1, etc. Okay, so we want to find out a sublist, a continuous sublist, which has the absolute, what is this absolute value? What is this absolute value? What is this absolute value? What's this?
That's the absolute value.
What does it mean?
I work in.
ABS minus 10, what does it equal?
It means like, is it a 10?
10, the distance to the 0, right? Basically, so the minus will
And
be
the
the negative. The negative value will be have this taken out, the minus and taken out. Okay. Absolute 99 equals what?
99.
Absolute minus 1, 2, 3 equals what?
1, 2, 3.
Exactly. Okay. So this is only difference. We want to find out the absolute value. So obviously we can use the first two approach. Yeah, the brute force on cubic, exactly. Yeah, on square. Yeah, I'm not going to write it. It's basically similar. We just have to put one more absolute value. Yeah, but how can we apply this Kadane or dynamic programming approach to this kind of problem, right? With this absolute keyword. What's this absolute keyword actually? So you will make you'll be actually the distance to the 0, right? So there are only two possibilities. Either you go very, very far to the right, or you go very, very far to the left, right? So in this case, we can use two values. One is to store the maximum sum of the sublist we have seen so far, and the other one is what? We find the minimum sum of the sublist we have seen so far, right? Yeah. So how can we apply this? This is quite interesting. Look, so we just have to do this, right? Current, we just have to put this current into there's a low, and then also equals the high. Okay. Yeah. Then this is the same. We do this. The high equals maximum high plus I, and then we add one more. Low equals the minimum low plus I. Then answer equals maximum answer. Okay, so there are two more values: high or minus low, right? Okay, and then return answer. This is only changes. Right? Come on, this is the takeaway of today. This is the new thing today. Do you get this problem? We are adding this absolute value. Absolute value is basically the distance to 0, right? And we are finding this absolute value. So it could be only two choices. Either you go very, very far to the right, which is to the east, yeah, or you go very, very far to the left, which is to the west, yeah. All right, east, west, north, south. Okay, so we basically two choice. We can track the largest value like going east, or we can check the largest value going west, right? So instead of checking the one single value, we have this low, and maybe we just change it to east and west. Okay, east and west. So east will be maximum, east plus I. The west will be minimum, right? Because going left will be the minimum. So we go to minimum plus I, and then going east or minus going west. So this is the same thing as taking the absolute value, yeah? Because we know the west will be the negative number, so we just do this minus W. So this is basically the same as like we are applying the Kadane algorithm twice on this problem, okay? Yes? What's the time complexity for this one? Come on, if you look at
N.
N, right? Yeah, because we're iterating once of the array, and then we are tracking the maximum and minimum value, okay? Yeah? Yeah, what have you learned today so far? Come on, one sentence. One sentence.
I learned the largest sublist from.
Yeah?
Yeah.
What have you learned so far? Come on.
The largest sublist from
Of what? What's the difference between sublist sum?
Sublist.
ADS.
Yeah, absolute. The largest absolute sublist sum. Okay, so today is we are just adding a keyword ABS here. Absolute sublist sum. Okay, and then how do we do it? We're just applying the Kadane algorithm twice. Kadane is basically the iterated dynamic programming. Yeah, dynamic programming. So it's let me just write it again one more time. Okay, write it. So DPI is the what's DPI? Numbers I. Okay. Let me explain this one more time, Eric. So this is the key takeaway of the dynamic programming. DPI is the largest sublist sum that ends at index I. Yeah? So we are looking at this number. So the largest sublist sum, we can try to include this number in the previous sublist sum, right? And plus it. Or we don't pick the previous one, then we start with this kind of number. So look, 1, 2, minus 4, 5. Okay, so if we are looking at this number, so there are two choices. We can include this minus 4 in the previous sublist sum. Yeah, previous sublist sum is DPI minus 1 here. So I don't know which one is maximum, right? Which one is higher? So basically DPI minus 1, come on, is the sublist sum of the previous here. Yeah, I can include this number, right? So the previous sublist will include one more minus 4. Or I decide I can drop it. So I start a new list from here, right? Yeah? Do you get it? Do you get it? Right? This is basically it, okay? And then plug 0 means that we are dropping the previous sum, right? And then we start with a new one, right? Okay? That's it for today. Bye bye. Bye bye. Bye bye.